Somewhere beneath your feet, hidden under dirt, grass, and the chaos of modern cities, lies a technology so advanced, it has outlived empires. Roads built over 2,000 years ago, still straight, still solid, still resisting time itself. Not cracked highways patched every decade, but ancient stone paths that refuse to die. This is not just engineering. It's a mystery. How did a civilization without modern machines create infrastructure that modern nations struggle to maintain? Why do Roman roads survive earthquakes, floods, and centuries of neglect, while many of ours fail within years? Historians once believed they were simple, just stones laid over dirt. But the deeper we dig, the more unsettling the truth becomes. Because Roman roads were not just roads. They were something far more calculated, almost surgical in design. And what lies beneath them may completely change how we understand ancient intelligence. Everything we thought we knew about ancient engineering is wrong. Imagine standing in the middle of a dense European forest at dawn. The mist hangs low, silent, almost watchful. Beneath your boots is a narrow stone path, uneven, weathered yet impossibly firm. You press down, expecting it to crumble. It doesn't move. It hasn't moved in nearly 2,000 years. This is not an isolated relic. Across continents, from Britain to the Middle East, over 400,000 kilometers of Roman roads once stretched like arteries across an empire. Not dirt tracks. Not temporary routes. Precision-built corridors, many still visible today. Some still in use. Now ask yourself something unsettling. How is it possible that these roads, built without modern machinery, without asphalt, without reinforced concrete, have outlasted modern highways engineered with satellites and computers? Because this wasn't just construction. It was strategy. The Romans didn't build roads to connect cities. They built them to control the world. Every road was designed with military precision, straight lines cutting through mountains, valleys, and rivers, ignoring the natural curves of the land. To the Romans, efficiency mattered more than comfort. Speed over ease. Power over convenience. But here's where the mystery deepens. Modern archaeologists have uncovered sections of Roman roads buried deep beneath layers of earth, and what they found was not simple. Beneath the visible stones lies a complex, multi-layered structure. Carefully arranged materials. Different densities. Drainage systems hidden beneath the surface. It's almost as if these roads were designed to breathe. To adapt. To survive. And they did. While modern roads crack under pressure, heat expansion, water damage, shifting soil, Roman roads seem to resist these forces. Not perfectly, but unnaturally well. Some sections have endured earthquakes. Others have survived centuries of abandonment, only to be rediscovered, still intact. So the question becomes unavoidable. Were the Romans simply better builders? Or did they understand something about the earth itself, something we have forgotten? Because when researchers began to analyze the composition beneath these roads, they discovered something unexpected. Not just stone. Not just gravel. But a deliberate system engineered to distribute weight, repel water, and stabilize the ground beneath it. This wasn't primitive technology. It was advanced thinking. And perhaps even more disturbing, it was consistent. Across thousands of kilometers, the same principles appear again and again. As if the entire empire followed a hidden blueprint. A blueprint that worked. But why? Why invest so much time, labor, and intelligence into something as ordinary as a road? Unless the roads were never just roads at all. Unless they were the foundation of something far greater, an invisible network that allowed an empire to move, to control, to dominate faster than any civilization before it. And if that's true, then what exactly lies beneath those stones, still holding them together after 2 millennia? To understand why Roman roads still exist, you have to go beneath the surface, literally. Strip away the top layer of worn stone, and what you find is not random rubble, but a system so deliberate it feels almost modern in its logic. First comes the statumen, a foundation of large, tightly packed stones, forming a rigid base. Above that the rudis, a thick layer of crushed stone mixed with lime, compacted into a dense, almost concrete-like mass. Then the nucleus, a finer blend of sand and gravel, carefully leveled to distribute weight evenly. And finally the summum dorsum, the visible surface, often made of precisely fitted stone slabs. 4 layers. Each serving a purpose. Each interacting with the others. This wasn't construction. It was engineering. Modern roads often fail because they fight against nature. Water seeps in, freezes, expands, and fractures the surface. Soil shifts, pressure concentrates, cracks spread like fractures in glass. But Roman roads were designed to cooperate with the earth beneath them. They were slightly curved, almost imperceptibly, allowing rainwater to flow off the surface instead of pooling. Beneath them, hidden drainage channels carried moisture away, preventing erosion. The layered structure didn't resist pressure, it absorbed and redistributed it, like a living system adjusting to stress. In a way, Roman roads behaved less like rigid objects, and more like flexible organisms. And then there's the material itself. The Romans used a form of early concrete, opus cementitium, mixed with volcanic ash in some regions. This wasn't ordinary binding material. When exposed to moisture, it didn't weaken. It strengthened. Chemical reactions within the mixture created crystalline structures that reinforced the road over time. Think about that for a moment. A material that becomes stronger as it ages. That's not just durability. That's self-improvement. Even today, scientists study Roman concrete to understand how it resists cracking and degradation. Some of the mechanisms behind it are still not fully replicated in modern construction. But the real revelation comes when you step back and look at the system as a whole. Roman roads were not built randomly. Surveyors used tools like the groma to align roads in near-perfect straight lines over vast distances. Engineers calculated gradients, ensuring that even over hills and valleys, the road maintained structural integrity. They didn't just build roads. They built networks. Every layer, every angle, every material choice was part of a larger design, a design that allowed legions to move with speed, supplies to flow without interruption, and communication to travel faster than any rival civilization could match. But here's the twist that unsettled historians. Not all Roman roads followed the same exact blueprint. In different regions, materials changed. Techniques adapted. Yet the outcome remained the same: remarkable durability. It's as if the Romans understood not just one formula, but a principle. A deeper knowledge of how terrain, pressure, water, and time interact. A knowledge that could be modified without being lost. And that raises a question far more profound than how they built these roads. It forces us to ask: did the Romans simply discover this knowledge through trial and error? Or did they inherit it from something older, something already understood long before their empire ever rose? If Roman roads are still standing after 2,000 years, the real question is no longer how they were built, but what that says about us. Because somewhere along the timeline of human progress, something strange happened. We advanced in technology, but lost durability. Stand on a modern highway and you'll see constant repairs, cracks sealed, surfaces replaced, entire sections rebuilt within decades. Yet beneath forests, deserts, and cities, Roman roads remain, quiet, stable, almost defiant. This is not just a story about engineering. It's a story about priorities. The Romans didn't build for convenience. They built for permanence. Every road was an investment not in years, but in centuries. Labor was immense. Time was irrelevant. What mattered was endurance. And that idea feels almost alien today. We live in a world optimized for speed, cost, and short-term efficiency. Infrastructure is designed to be replaced, not to last. Planned obsolescence is not a flaw, it's a feature. So when we look at Roman roads, we're not just looking at ancient technology. We're looking at a different philosophy of civilization. A civilization that assumed it would endure, and built accordingly. But there's a deeper implication, one that unsettles historians and engineers alike. If ancient societies could create systems that outperform many modern equivalents in longevity, what else have we misunderstood? Because Roman roads were not isolated achievements. They were part of a broader network of knowledge, architecture, aqueducts, materials science, that still puzzles researchers today. And in some cases, we still cannot fully replicate what they achieved. This raises a possibility that is both fascinating and uncomfortable. That progress is not always linear. That knowledge can be lost. That civilizations can forget things they once understood. And if that's true, then Roman roads are not just relics of the past. They are warnings. Warnings that even as we move forward, we may be leaving something behind, something fundamental about how to build in harmony with time, not against it. Because time is the ultimate test. It erodes everything. It breaks down the strongest materials, collapses the greatest empires, rewrites landscapes, and buries entire civilizations beneath layers of dust. And yet, these roads remain. Not untouched. Not perfect. But enduring. Still guiding footsteps. Still shaping paths. Still resisting the slow, relentless force that destroys almost everything else humanity creates. So when you walk on a Roman road, you are not just stepping on stone. You are stepping on a message, sent across 2,000 years. A message that whispers something both simple and profound. That true mastery is not measured by how fast we can build, but by how long what we build can stand. Because civilizations rise in moments, but they are remembered by what they leave behind.